In today's lesson, I'm going to write linear equations given two different scenarios. The first scenario is when we're given a graph. We're going to write the equation of the graphed line. Step number one is to find the y-intercept. Looking at the y-axis, which is the vertical one, we have a y-intercept of 2, 0, comma 2, meaning really just 2. Then we'll draw a second point on the line. Remember, points want to be nice and on the coordinate plane on a perfect kind of intersection. Here's a good one here. Again, there's multiple options, but I'm choosing this point here at 2 comma 4. I count the rise over the run. Rise is always how far up I go, which is going to be a positive 2 if I'm counting left to right. So I went up 2, meaning it's a positive 2. Then I go ahead and run it, and I'm going to be running to the right 1, 2. When I run to the right, it's going to be a positive 2, and that's going to simplify to a positive 1. 2 divided by 2 does come out to be 1. We're going to replace the slope, which is our m. So again, our slope was 1. And then we're going to replace the y-intercept, which was 2, into slope-intercept form. So my final equation is y equals, instead of mx plus b, I have the slope, which is 1, and the b, the y-intercept, which is 2. I just replace them as so. You might see this also written as just y equals x plus 2 instead of y equals 1x plus 2, but both are correct. Let's go ahead and try the next one. For the next example, again, we want to go ahead and start by finding the y-intercept on our y-axis, which will be at negative 2 this time. 0, comma negative 2, and just negative 2 for our purposes. We go ahead and then draw a second point on the line. Remember, it can be anywhere that is perfectly on a vertical and horizontal intersection. I couldn't have selected any point between my purple and green because those would be on decimals. They're not perfectly fit on the grid on a horizontal and vertical line. From here, we count rise over run. So again, we go ahead and count left to right. You could do right to left, but I'm going to do left to right to keep it consistent. Down 1, 2, 3. And when I go down 3, that is going to be a negative 3 overall. And then I go ahead and do my run, which is my left or my right. In this case, to get to my point, I must go right, which is going to be a positive operation, 2. That's how far I go right, 2. And that's going to be a positive 2. Overall, my slope is negative 3 over 2. That's going to be my slope, which is my m, so it goes in front of the x, and negative 3 over 2. After the x added or subtracted is our y-intercept, which in this case was a negative 2. I won't keep it as plus minus. I'll keep it as y equals the mx plus b, with the m being replaced with negative 3 over 2 in front of the x. And I will then subtract my b value here. Helps me get my final answer. Make sure you keep the y and the x in the equation. Looking at the horizontal line special case, we're looking to see which axis it passes through, and it's going to be the y-axis. When it passes through the y-axis, we have a y equals equation. What it equals to is what specifically it's passing through at, which is a positive 2. That's where it passes through the y-axis, so y equals 2 is our equation. The next special case is going to be a vertical line. We see what axis is passing through, and that's going to be the x-axis, so we start our equation with x equals. Depending on the axis is what you end up passing through and having your equation equal to. Now, what it's equal to, well, where is it passing through the x-axis at? That's a negative 3. And so your equation is negative 3. X equals negative 3. We talked about another scenario. In the second scenario for this video notes is going to be when given slope and a point on the line. For example number 5, we want to write the equation of a line with the given slope and a point on the line. The slope is going to be 4, which is going to be our m value. Slope is always m in my equation. A point on the line, negative 1 comma 1, is always going to be, in this case, an x and a y. That's what points usually are, and that's what we're going to plug into the equation. So I plug in all of these accordingly here. Into y equals mx plus b, my slope-intercept form I'm always using here when I'm writing these equations given a graph, or in this case, given a slope and a point. The y is going to be replaced with what y is equivalent to, which is 1. I keep the equal sign. My m is going to be replaced with what it's equivalent to, which is going to be 4. That's my slope. The x is going to be replaced with what it's equivalent to, which is the negative 1. And then I keep plus b because I do not know that substituted letter to be filled in. And that's what I need to solve for. I go ahead and draw a line and solve this one out. Well, I want to go ahead and combine any like terms. I can right away combine this 4 times negative 1 to become a negative 4. Bring down the 1 and the plus b I did nothing with. To get b all alone, I have to move over the negative 4 by doing a plus 4. It's going to the opposite side, so I need to do the opposite operation. Negative 4 plus 4 cancels out, and 1 plus 4 comes out to 5. This ends up being 5 is equal to b all alone. Now that I have what b is equal to, I can write my final equation. Don't stop there. You have to plug in the final equation by plugging in the slope in front of x, so that would be a positive 4. And then after x being added or subtracted, in this case added, is a positive 5. Final equation is y equals 4x plus 5. We're substituting in the m and the b into y equals mx plus b with the m that was given in the problem and the b that we solved for. We must keep the y and the x in the final equation because we have to account for every point on the line, not just the point negative 1 comma 1 in this scenario. Next example here, number 6, we want to write the equation of a line with the given slope and a point on the line. Again, we go ahead and identify that m is going to be negative 5 over 6. And then our x in this case is going to be a positive 6. And the y is going to be negative 2. I go ahead and label everything I'm given appropriately. Points are always x comma y, and our slope is always m. We substitute it in always into y equals mx plus b. You're going to remember and want to remember that slope-intercept form equation. Well, the y is going to be substituted in for negative 2 because that's what y is in this situation. Keep the equal sign, bring it down. The m in this situation is going to be negative 5 over 6, so we substitute that in. Fraction and all. The x is going to be 6. And we bring down b because we do not know b, so therefore we need to solve for it. If you don't know a certain letter, you must solve for it. But we have everything else. No other letter is necessary. Every other letter is known. So we can go ahead and solve. Remember that with fractions, you want to multiply across. I put any whole numbers over 1 and I multiply straight across. Negative 5 times 6 is going to be negative 30, and 6 times 1 is going to be 6. And I bring everything else down. Once I multiply the fractions across, it's just going to be division here. Negative 30 divided by 6 is just negative 5 in your calculator. To get my variable all by itself, I must move over that negative 5. Opposite of negative 5 is a plus 5. What you do to one side, you have to do the other. Negative 5 plus 5 cancels, and negative 2 plus 5 equals 3. That's what our value of b is. Are we done? No, we got to write the equation. Well, I'm going to write the equation as y equals mx plus b. The only two letters I substitute by erasing are the b, which is going to be 3 that I solved for, And I go ahead and erase and replace m, which is going to be what was given in the problem, -5/6. Final equation reads y equals -5/6x plus 3. Make sure you write the final equation to answer the question. Example number 7 again says write the equation of a line, so we can't stop until we write an equation with the given slope and a point on the line. Well, the slope is always going to be what I substitute in place of m. Label it as m. Point gets labeled as x comma y. X goes first, so x is going to be 4, and y comes second, so y is going to be 5. We go ahead and write y equals mx plus b because that's my slope-intercept form. I have to substitute in what I know. I know the y in this case is a +5. I know the m in this case is going to be 3/2. And I bring the equal sign down. And then I know the x in this case is going to get multiplied to m, so that's going to be a multiplication of 4. Bring down the plus b, can't forget that I have to have this equation. And solve for b because I don't know it yet. Remember, when you are multiplying fractions, put any whole numbers over 1 and then multiply the numerators together, the top of the fraction, and the two numbers on the bottom of the fraction together. 5 equals 3 times 4, which is 12, over 2 times 1, which is 2. Don't forget to bring down the plus b that we did nothing with yet. Now that we multiply the fraction, numerator and denominator, so two numbers on the top with the two numbers on the bottom, we go ahead and divide. 12 divided by 2 comes out to be 6, and I add b to that. Because I have to get b all alone, I have to move the 6 over to the other side. What I must do is the opposite of a +6, which is a -6. I do that on each side. 6 minus 6 is 0, and that leaves me with just b on the right. On the left side, 5 minus 6 is a -1. That's going to be my y-intercept, my b. Well, that goes into my y equals mx plus b equation. Where b is, I go ahead and erase and replace it with -1. I'm going to take the plus with it as well because I don't want to have it be plus -1. I'll keep it as a -1 overall. And then I go ahead and erase and replace my m, plugging in what my m is in this problem, which is 3/2 that was given. Final equation reads y equals 3/2x minus 1. Remember to always keep the y and the x in the equation. Only substitute m which you're given and b which you solve for.